Listen, whenever you see cos 25 as k, there are many different ways of doing it, but when, you know, one time I was visiting Nelson at where he teaches, and this is exactly the Nelson approach, and I think it's brilliant. I mean, this guy, as I said, he should have been our maths teacher because he's good. And this is what he does. He draws a diagram. Now, people look at this. When you've got cos 25, firstly, the most important thing here, you've got cos 25 is equal to k, but we're going to put it over 1 because cos is x over r. Now, Nelson, this is the first quadrant. So if we draw a diagram, I'm going to draw it up, and then I want you to tell them exactly how you approach this, because this is maestro mathematics. Okay, first quadrant is 25 degrees here. Okay, 25 degrees in the first quadrant, and we can create a little triangle, and we know that the cos is x. We don't know what the y is, but we know that the r is 1. Now, how do you take the learners from here? What would you do?
That we need the y from theorem of Pythagoras. So this is in the first quad. It states 1 squared equals, okay, we've got that, k squared plus y squared. But we need y. Okay, y squared equals 1 minus k squared. From there, find the square root of that. Okay, last time we talked of plus or minus here, Mark.
Yes.
And then now we have 1 minus k squared. Why can't we have minus here?
The important thing, guys, you're in the first quadrant where x and y are positive. So you keep it. And the other thing, Nelson, matrics, be very careful of this. You know what some matrics want to do here? They take this. Y most definitely does not equal 1 minus k. Be very careful with that. That's a big mistake there. You keep it as that thing. Now, let's just summarize what we've got, and then we can go through the first question. If you have a look here, we know that x is equal to k, that y is the square root of 1 minus k squared, and then your r is equal to 1. So now, if you want to work out the sine of 25, what do we do, Nelson?
Y over r. Sine 25 is y over r, and the y value is the root of 1 minus k squared, then the r is 1. You can leave your answer like this, or simplifies to square root of 1 minus k squared.
That's good. There are other ways of doing it, but the diagram method is the best, is absolutely best. Now let's go and look, let's have a look at the next one. What does it say, Nelson?
Tan 155 degrees.
Okay, tan 155. Let's go and have a look here. Okay, here we go. Tan 155. Now, the important thing is that we've got to get this to 25. But that's very easy because what quadrants are we in?
We're in the
in the second, which is clearly going to be that.
180 minus 25.
Okay, which reduces to negative tan 25. These diagrams are so important. And what do we know about tan?
Tan is y over x.
Is the y over the x, which is going to be the square root of 1 minus k squared all over
k.
Okay, there we go. And that's pretty straightforward there. Okay, and now, this is a Nelson favorite. He always puts this in his papers. How would you handle the sine of 65? Check this out. Do you want to take them through this, Nelson?
Sine of 65, that is, again, it agrees to Kokoro. 90 degrees minus how much? 25.
Definitely 25.
Then that goes to, first quad changes to cos of 25. And then what is cos of 25?
Very simply
That
k.
is x over r, which is k over 1, which is k.
Absolutely. Now, that's amazing when you do that there. Okay, now the other thing is, guys, watch out for this. They love these sort of questions. If you have a look at another one, let's go and have a look here. These are really, really cool. If you take sine 410, well, Addo, we've got a problem here, sister.
What's the problem?
This guy, 410, is an angle bigger than 360. He's got an inflated self-image, and you don't want a guy like that.
No.
You want a humble guy. So what are we going to do? We're going to bring him down a bit. So how do we do it? We subtract 360.
410 minus 360.
Okay, so if we subtract We're going to go there to sine 50. If you just simply subtract 360 from this, it'll go straight down. And guys, they will give you the marks for that. Now, Nelson, here's a problem. 50, what would you suggest?
But we can. 50 is double 25, not so? If you double 25, you get 50. And this is double angle to sine.
Yeah.
Expand it to sine 25, the cosine of 25, the cosine of 25. And then it's a matter of substitution.
And then very simply, if we put that in, what do we know about this? This is so important. Go and check those past papers, especially the prelim. They love this sort of thing. You also get the normal ones with the normal Pythagoras diagrams, but this is very important. Okay, and then all you can do is you evaluate this. Let's just go up here is equal to 2. The sine of 25 is that,
Yeah.
and the other one is,
Cos
of course,
25
k.
is the given one is k,
And we've
which
got
is 2k,
Yeah, absolutely.
square root of 1 minus k squared.
Very, very important, these kinds of questions. And watch out, compound and double angles often gets asked into this thing. By the way, the other method that they could use if you take sine 25, just watch this. This is quite interesting. I've seen this before. Ada, you'll love this one. If cos 25 is k, the other way you could do it is if you want sine, you know that sine squared 25
plus cos squared 25 is 1.
is 1.
Yeah.
Okay, now bring that across. So cos squared, in other words, you can say sine squared 25 degrees is equal to 1 minus the cos squared of 25. Okay, and then you've got that as k, so it's 1 minus k squared. So sine 25, there we go.
Okay.
Another approach. Okay.
All right. It's easy stuff, eh, when you're looking at it.
Absolutely.
I think it becomes so much easier to work through once you've done it and you know all the rules and you know everything that you're supposed to know.
Yeah.
Okay, we've got a caller from Ekaya, who, Elizabeth from Limpopo, wants to know exactly what it is, or she's got a question for us, for our teachers here. So let's speak to Elizabeth. Hey, Elizabeth.
Just before we go, moments of
Hello.
prayer. We need a moment of prayer. Elizabeth, you're not going to harass us, eh? Okay. Okay, go for it. Go for it, girl.
Oh, my question is that Mike and Nelson were right when they say, like, many of us don't know how to touch lock on the calculator. So I'm just having that problem. I mean, like, I know how to work the financial years, but then when it comes to finding number of years, I can't do it.
Okay, is that with the working of the logs?
Yeah.
Yes, Elizabeth, very, very important. Do you find that you always work with N and you have a big problem?
Yes, I mean, like, I know how to, like, get the formula and get everything right. I just can't seem to finish it up.
To get it to the end there. Okay, so do you know, so let's just look at an example quickly. If we take that one that we did, Nelson.
Yeah.
Are you happy if we said, say, 300,000? Okay.
Yes, I'm happy there.
Are you happy? You're happy with this? So it's 150,000. I'm
So
going to do...
far, what I couldn't do is log 1,015.
Oh, yes.
I don't know if it's into 2 or what. Then it's called to 12N.
Okay,
Okay.
12N. And do you want to know how to go from here?
No, how to go, like, punch it on the calculator.
Okay, all right. Very, very, very easy to do. Look, if you take your calculator quickly, okay.
Yes, I've got my
what we've got is,
calculator.
you've got the Casio, you've got the Sharp as well. But using this calculator, you would go firstly divide both sides by 150. So 300,000 divided by that, watch here, is 300,000. I don't know if you can see the calculator there, but it's 300,000 divided by 150,000 gives you 2. Are you okay with that?
Yes, I'm okay with
All
it.
right. Now, Elizabeth, are you okay up to this stage?
Yes, I'm
Right.
okay
Now,
with
the
it.
trick is how do we go from here? Is that your problem? Okay. All you do is, this is very easy. See this guy, this is a base, and he is tired of being dominated by 12N. This high and mighty exponent is giving him a hard time. So he says, I'm going to the other side. So he moves to the other side, and you put a log 2, and you go 1,015 equals, and the 12N drops down. So you take that guy and you put him as a base there. Is that okay?
Okay.
Do you understand this step?
Okay, and then you go to the button.